Welcome to Study Loop.
This is chapter 27, problem number 28. We are given a beam of electrons under the influence of electric field and magnetic field. Electric field and magnetic field both are perpendicular with respect to each other, and also they're perpendicular with respect to the velocity of the beam. So, and we want the speed at which the fields produce no deflection. So for this to happen, first of all, the electric force acting on the beam has to be equal to the magnetic force. From here, Q times E equals to QVB. As you know, there's a sine theta here, but B is perpendicular to B, so our angle is 90 degrees. Sine 90 is going to give us 1. From here, by canceling out the charges and then dividing both sides by the magnitude of the magnetic field, we get, for speed, we get E over B. Then when we plug in the numbers, 1.56 times 10 to the power 4 divided by 4.62 times 10 to the power negative 3, we get 3.38 times 10 to the power of 6 meters per second for the speed. In part B, we are required to sketch the directions of the fields and the direction of the velocity vector. So the most important thing here is that the fact that they're all perpendicular with respect to each other. So assume that we have a B field that goes into the page or into the screen. So this is the direction of B. And then let's assume that the particle is entering this field with this initial speed and the direction towards, let's take it towards right. And then if you take the direction of the electric field to be down, then let's see what's happening, whether or not this condition is satisfied. So then this is a negative charge, right? This is an electron. So from the right-hand rule, the direction of the magnetic force would be down. And if you pick the electric field to be down, then since it's a negative charge, the direction of the electric force would be up, so that we would be actually satisfying this condition. So this could be very well a sketch of what's going on. So in part C, actually, the electric field disappears, so we're only left with the magnetic field. So then the magnetic force is going to be equal to QVB. Again, there's a sine term here, but the angle is 90 degrees. I'm not writing it down. This is going to be equal to mv squared over r. And in this part, we are asked to actually calculate the radius. So then these are going to cancel. Let's isolate r out of this equation. Then r is going to be mv over QB. So when we plug in the numbers, 9.11 times 10 to the power of negative 31 times the speed, which we calculated to be 3.38 times 10 to the power of 6 from part A. And then we're going to divide this by the charge of an electron, 1.6 times 10 to the power of negative 19 times the magnitude of the magnetic field, which was given to us as 4.62 times 10 to the power of negative 3. So from here, we find the radius to be 4.165 times 10 to the power of negative 3 meters. Now, also in this part, we're asked to calculate the period of this rotation, right? Because it's a circular motion. The period is going to be the distance traveled. In that case, it's going to be 2 pi r, the circumference of that circular trajectory, divided by the speed that we calculated, right? So 2 times 3.14 times the radius that we just calculated, 4.165 times 10 to the power of negative 3 divided by 3.38 times 10 to the power of 6. So what we have for period is 7.74 times 10 to the power of -9 seconds.